second lecture in organic chem. So this is organic chem part 2, and this is what I really like, hydrocarbons. Okay, you already know what a hydrocarbon is, even though I didn't tell you. This is a hydrocarbon. All right, it consists of carbon and hydrogen, hence hydrocarbon. This is the simplest hydrocarbon. All right, it's a tetrahedral structure. It has polar bonds, like we said in the last video, because carbon's slightly more electronegative than hydrogen, so carbon pulls the pair a little bit closer to it. All right, but it's a tetrahedron, so that means it's symmetrical, so that means that this is nonpolar molecule. So when we talk about hydrocarbons, you always think about this one. Now, like I said, this is hydrocarbons, and you have a bunch of notes that I gave you on organic, but you don't have the notes on hydrocarbons because you actually have to see it and write it down in your black notebook. So I expect when you watch this video, I want you to write down this lecture because this is not in your notes. And it is very important. It's the building block of all organic chemistry. All right? Okay, so hydrocarbons. Number 1, obviously, made of hydrogen and carbon. So, they're only made of hydrogen and carbon. Number 2, sources. The biggest source is petroleum. The other source is coal. So, the 2 main sources, petroleum and coal. That's number 2. All right? Number 3. All hydrocarbons can burn. Or combust. All right? You need a little oxygen, hydrocarbon, and it combusts. All right? Number 4. Now, all right, there are 3 groups of hydrocarbons. Now, you've never seen homologous series before, but you have heard of the words, hopefully, homologous chromosome. Homologous chromosomes, you have a male chromosome, female chromosome, they make a homologous pair, which means they have the same properties on both sides, both male and female chromosomes. So homologous series means basically every hydrocarbon in that series has the same chemical and physical traits, okay? And there are 3 groups of hydrocarbons. So we're going to be talking about homologous series of hydrocarbons. All right. So, for this one right here, I'm going to put a little asterisk, and now we're going to go over what a homologous series is. Okay, so the first thing about a homologous series, they're all related. So, homologous series has members that have all the same chemical and physical properties, very similar to each other. That's a homologous series. All right, that's the first thing. Number two, okay, this is an important one. You don't know what general formula means. We will find that out a little bit later on. So, all the members have the same general formula. In other words, if you use this formula, you can figure out what the properties and physical and chemical properties are. Okay, all the members have the same general formula. And the next one is really important. Okay, this is number 3. Yeah, this is the important one. If we're only going over the first 10 members of each hydrocarbon series or homologous series, each member differs from the next member by 1 carbon and 2 hydrogens. Okay? That is very, very important. So those 3 things are what make up the definition of a homologous series. All right? Homologous series, the same throughout. Now, what we're going to do is there are 3 hydrocarbon series, and we're going to go and start the first one. And the good news is this. This is the first member of the first homologous series of hydrocarbons. And you know this is called methane. So, here we go. This is going to be Roman numeral 1. And the name of the first series, homologous series or hydrocarbon series, they are called the alkanes. Alkanes. There's another name for this series, and it is this one. So they can call it the alkane series or the methane series. So we're going to go like this. So, the alkane series or the methane series. All right. Number 1. This is something brand new. You really have to understand number 1. Now, the alkanes, like this one, they are considered saturated hydrocarbons. Now, what does that mean? Saturated simply means this. The carbons are totally saturated with hydrogens. In other words, remember, carbon needs 4 bonds around it at all times. Well, for methane, it has 4 hydrogens. And I don't care how many carbons there are, but they have to be saturated with hydrogens. Okay? So, here's a little bit more definition of what saturated hydrocarbon means. The alkanes are considered saturated hydrocarbons. Now watch. So, like this one, all single bonds between the carbons, all right? That's the alkane series. So, all single bonds between the carbons and saturated with hydrogens. Now, this is a super important property of alkanes. They are considered saturated hydrocarbons, like I said. So what that means is, look at, here's 4 of them. 4 carbons put together. And you see all single bonds between the carbons, and the rest of the bonding in the carbons is full of hydrogens. This is a saturated hydrocarbon. The alkanes are saturated hydrocarbons. Super important. Number 1. Number 2. So, slow reacting. Remember what we talked about before. The organic compounds have so many bonds, we have to break a ton of bonds in order to make them react, and that means you got to have a really high activation energy. So that's why they're slow reacting. That's number 2. Number 3. I'm going to write this down, but we're going to figure it out later. So number 3 is this. So you're going to leave that blank when you're writing these down. The general formula is, okay, we'll come back to number 3. Number 4, this is what I had you hopefully memorize for the last video. Remember, meth, eth, prop, but, pent, hex, hept, oct, non, dec. You have to memorize those. So we're going to go over them right now. So number 4 is going to be naming. And what we're going to do is we're going to indent and put down number 1. All right, so I'm going to erase this and start up here. Number 1. If it's 1 carbon, the prefix is meth. And since this is the alkane group, this is methane. So that is methane. All right? Formula. It looks 1 carbon. And it looks like that, like you know, that is methane, and that's the structural formula. The chemical formula is CH4. Name, structural formula, chemical formula. All right? Now, the next one But since it's the alkane group, that's ethane. And here's what this looks like. Now, eth means got two carbons. And remember, the alkanes are saturated. So all single bonds between the carbons and totally surrounded by hydrogens. So that's ethane. All right? So look, this is methane. This is ethane. Okay? Methane and ethane. The chemical formula, there's two carbons and there are 6 hydrogens. So that is C2H6. Now, do you remember what I said about homologous series? They all have the same chemical and physical property, they have the same general formula, and they all differ from one another by 1 carbon and 2 hydrogens. Look, there's 1 carbon and 4 hydrogens. The next one down, you add 1 carbon and 2 more hydrogens. So there's 2 carbons, add 2 more hydrogens to that, so that's C2H6. So even if we don't draw the next structure, we can figure out what the formula is by adding 1 carbon and 2 hydrogens. So look at C2H6. Let's add 1 carbon and 2 hydrogens. So the next one down, its molecular formula must be C3H8. That's what it's got to be because each member differs from the next member by 1 carbon and 2 hydrogens. So let's go backwards and build this. 1, 2, 3. So that's what it looks like. 3 carbons. Here it is right here. 3 carbons, single bonds between the carbons, and totally saturated or filled with hydrogens. Now, we have methane, ethane. The third one down is an easy one to remember because all the people use it in their gas grills. Number 3. Propane. So, propane, there it is, C3H8. Okay? Now, we're going to go down to number 4. So it's meth, eth, prop. The number 4 is bute. Butane. That means 4 carbons. Now, for speed's sake, I'm not going to put the hydrogens in. Each dash goes to a hydrogen, all right? So if you count these up, it's going to be C4, and then how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. So, that is butane. And butane looks like this. Now remember, they don't have to be a straight line. They can be all crooked like this, as long as they're all together. All right, so that is butane. Number 5. Number 5 is pentane. Now, remember, each member differs from the next member by 1 carbon and 2 hydrogens. So if butane was 4 carbons and 10 hydrogens, then pentane has got to be 5 carbons and 12 hydrogens. C5H12. But let's just see if that's true. 1, 2, 3, 4, 5. We got 5 carbons. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 12 hydrogens. All right? 5 carbons, 12 hydrogens. That's pentane. Okay? I don't have to go all the way through this with you. But your first thing you're going to do is you're going to email me these first 2 questions. So, for number 6, that is hexane. And you, for your first questions, are going to build it, and then you're going to write, this is called, remember, this is the structural formula, and this is the molecular formula. So you're going to do that for hexane. And you're going to do it for heptane. Okay? So, you are going to do these 2. These are your first 2 questions from this video. I want the structural formula and the molecular formula for hexane and heptane. All right? We'll go back to this in a little bit, but now we have to go to our second homologous series or second hydrocarbon series. All right? Now, this is Roman numeral 2, and this is called the alkenes. So the first one ended in ane, these end in ene. So these are the alkenes. Number 1. Now these are way different from the alkanes. Remember, the alkanes were saturated, full of hydrogens, all single bonds between the carbon. Well, this one, these are called unsaturated. Unsaturated hydrocarbons. Now watch why they're called unsaturated. It must mean that they don't have a total surrounding area of hydrogens. All right? Okay, so unsaturated hydrocarbons, watch. All right, this is way different. Look it. If it's unsaturated and it's an alkene, that means it has one double bond somewhere in the chain of carbons. All right? Remember, alkanes had all single bonds, but alkenes got to have a double bond in there somewhere. All right? So that's number 1, and we're going to go over how to name those in a minute. Number 2. These are faster reacting than alkanes. Okay? A little bit faster than alkanes. All right, number 3. And like we left number 3 blank for alkanes, we're going to leave number 3 blank for alkenes. Okay, we're going to go back to that later. Number 4. Naming. Now we're going to indent and put down number 1. But these are way different in the names. Remember, the first alkane was called methane. All right? Now, could the first alkene be called methane? No, it can't. Because the rule is, if you're an alkene, you have to have a double bond between two carbons. So there's no such thing as methane. So our first alkene has to have a double bond in it. So here is the first alkene. All right? So there's no such thing as methane, like I said. So the number one first alkene would be ethene. Structural formula, eth means two carbons. And since it's an alkene, it's got a double bond between them. Now, if it's got a double bond between them, how many more sites or how many more bonds does each carbon need? Well, each carbon already has two bonds, so it only needs two more bonds. And I'll put these in for you. So that's what it looks like. That's the first member of the alkene series. That is called ethene. And now we're going to look for, this is the structural formula. We're going to look for the molecular formula. Well, it's easy. There's two C's. C2H, 1, 2, 3, 4. C2H4. That's it. Now, remember what I said about a homologous series? Each member differs from the next member by one carbon and two hydrogens. It is the same for this one. So, for number 2, if ethene is the first member, then propene is the second number. But let's not build the structural formula. Let's look over here. Each member differs by one carbon and two hydrogen. So the molecular formula for propene must be one more carbon there and two more hydrogens there. So it must be C3H6. That's what it's got to be. So now let's look. Now look, there's a double bond. I can put it there or I can put it on the second one. I'll explain the difference a little bit later on. This carbon right here already has two bonds, needs two more. How many bonds does that middle carbon already have? 1, 2, 3. So how many more bonds does that middle carbon need? 1. This carbon already has one bond, so that must mean it needs 3 more. Okay, so remember what I said, for time's sake, I'm not going to put the hydrogens in, but let's count them and see. 1, 2, 3. We have 3 carbons, and 1, 2, 3, 4, 5, 6. We have 6 hydrogens, and that is called propene. Everybody got that? Okay. We're going to do one more, and then you're going to build 2 like you did for the alkanes. So our next one, number 3. Number 3 has 4 carbons, and the prefix for 4 is bute. So it's butene. Now we have 4 carbons. Now, remember, it's an alkene, so we have to put that double bond somewhere. And you can put it anywhere. We will learn how to name them a little bit later on. So let's just put it right here. So there's our double bond. Most importantly, you got to figure out how many more bonds each carbon needs. So this first carbon already has one bond, so this one needs 3. This carbon already has 3 bonds, it needs 1 more. This carbon, 3 bonds, needs 1 more. This carbon, 1 bond, needs 3. Remember, they're all hooked to hydrogen, but I don't have time to be drawing all those hydrogens in. So, that is the structural formula. Let's look at the molecular formula. Carbon, 1, 2, 3, 4. C4. Hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. So that is butene. Okay? Now, next. Number 4, we've already done, there's no such thing as methene. We've done ethene, pentene, and butene. What you have to do is you are going to build me this. You are going to build pentene. I want the structural formula and I want the molecular formula. And then you are going to build hexene. So remember, you have 2 to build for alkane, 2 to build for alkene. All right, now that's what I want you to do for that. And now what we're doing is we're going to go into our 3rd and final homologous series with hydrocarbons. Okay, so this is going to be Roman numeral 3. These are called alkynes. So look what we got. If it's all single bonds, it's alkanes. If there's 1 double bond in the carbon chain, they're called alkenes. For this one, there's going to be 1 triple bond. So we have anes, enes, ines. Single bonds, 1 double, and 1 triple. So, for number 1. And if it has a double or triple bond, it can't hold all the hydrogens it's supposed to hold. So this also is called unsaturated. This is the biggie here. So if it's an alkyne, it's got 1 triple somewhere in the carbon chain. All right? So we have alkanes are saturated, alkenes are unsaturated because they got a double bond, alkynes are unsaturated because they have a triple bond. For number 2. Of the alkanes, alkenes, alkynes, these are the most reactive. They react faster than any of the other alkanes or alkenes. All right? Number 3. Remember, number 3 for alkanes is general formula. We left that blank. Number 3 for alkenes, general formula. We left that blank. Same thing here. Number 3 for alkynes, general formula, but we're going to leave it blank. All right? And like we did for the other ones, number 4 is going to be naming. we're going to indent and put number 1. Now remember, for the alkanes, methane was the first member. This one. Methane was the first member for the alkanes. For the alkenes, the first member was ethene, because you need 2 carbons to have a double bond between them. Now, for the alkynes, you got to have 2 carbons to have a triple bond between them. So the very first alkyne is called ethyne. Ethyne. And it's a crazy one. Here's what it looks like. It's got a triple bond between the 2 carbons. Ethyne. So we're going to go like this. C, triple C. So if it's got a triple bond, that carbon already has 3 bonds, only needs 1. And that one only needs 1. So I'll draw these. So that's what this looks like. And that's C2H2. Number 2. Number 2, if ethyne is the first member, then propyne must be the second member. But if you remember, each member of a homologous series differs from the next member by 1 carbon and 2 hydrogens. So if this one is C2H2, we're going to add 1 carbon to that and 2 hydrogens to that, and we'll have propyne. So C3H4. That's what the structural formula should look like. So let's draw it. 1, 2, 3. And we got to put the triple bond somewhere. It doesn't make any difference where. Let's put it here. Now, there's only 1 bond going to the first carbon. That means it needs 3. But look at the second carbon. How many bonds are around the second carbon? 1, 2, 3, 4. That doesn't need any more bonds. That has 4 bonds around it. This one, the end carbon, has 3, so it only needs 1. So now let's see if we were correct with the molecular formula. 1, 2, 3 carbons and 1, 2, 3, 4 hydrogens. That's perfect. So that is propyne. All right? You have to do butane, the structural and the molecular formula. And then for number 6, you have to do pentane. So now, you have 6 drawings for me. Okay? You have 2 from the alkanes, 2 from the alkenes, and 2 from the alkynes. All right? Now what we're going to do is this. We are going to go back and try to figure out the general formulas for alkanes, alkenes, and alkynes. All right, so watch. Remember, the alkanes are all single. So the first alkane is this, and that's CH4. Now the second one is this, C2H6. Now, third one. Remember, they each differ by 1 carbon and 2 hydrogens. So put 1 more carbon there, 2 more hydrogens there. So this should be C3H8. But that's an easy way to do it. Every time you go down 1, add 1 carbon, 2 hydrogens. But what if I wanted decane? Decane is 10 carbons in a row. How would you figure out how to build that? If you didn't put the structural formula, how would you know what the molecular formula is? Now watch. look what's happening. Every time we add a carbon, the hydrogen number goes up by 2, right? So the general formula for the alkanes, if I double the carbon number and add 2, that's what I get. So let's go with decane. Watch. Decane. I know that that's C10 and H. Remember what I said? Double the carbon number and add 2, and you can find your hydrogens. So C10, double that would be C20, add 2, so that would be C10H22. So let's go with one that we already know. Let's go with butane. Butane is C4. Now, if it's an alkane, all you have to do is double the carbon number and add 2. So 4 and 4 are 8, and add 2 more, 10. So this is C4H10. So for that blank number 3 for alkanes, here's your general formula. Okay, so here's your general formula. CnH2n plus 2. You can write that in for number 3 under alkanes. All that means is if N is 4, you would have C4, and then 2N would be 8, and 2 more 10, it would be H10. So the way I remember it is for the alkanes, the general formula, double plus 2. Double plus 2 for the alkanes. All right? Now, let's go to the alkenes. Alkenes are the easiest. All right, so let's look at this. C2H4. All right, let's look at propene. C3, 1, 2, 3, 4, 5, H6. So if alkanes, you had to double the carbon number and add 2, what are you doing to find the hydrogen number? For this one, you just double it. You double the carbon number and you got it. So if we had to go C10, all you do is double the carbon number and you got the hydrogens. C10H20. So for number 3 under alkenes, if the general formula for the alkanes was this, you double the carbon number and add 2, that's for the alkanes. For the alkenes, you just double it. So it's CnH2n. That's all. That's an easy one. So that equals the alkenes. So we have the alkanes general formula. We have the alkenes general formula. Now let's look at the alkynes. Our first alkyne looks like this. Our second one looks like this. So let's look. 2 C's, 2 hydrogens. C2H2. Here we have 3 C's and 1, 2, 3, 4. C3H4. Now remember, each member homologous series differs from the next member by 1 carbon, 2 hydrogens. So the next one down, which is butane, would be add 1 there, C4, add 2 there, H6. So if the alkanes, you double plus 2 to get the hydrogens. Alkenes, you just double. Look at this one. If I doubled that, I'd get 6, but that's only 4. So for the alkynes, you double it, double the carbon number, but you have to take away 2 hydrogens. So here is number 3 for the alkyne series. CnH2n. H2N minus 2. CnH2n minus 2. That is it for the alkyne series. So the way I remember it, double plus 2, that's alkanes. Double, that's alkenes. Double minus 2, that's alkynes. Okay? These are the 3 homologous series of hydrocarbons. You have 6 questions from here to do for me.